Welcome back. This is Mrs. Rubright with Algebra 1 Honors. Today's lesson is 4-7, point slope form. So we've already done slope-intercept form. We've already done standard form where we use our x and y intercepts to graph. And now this is one more form. It's point slope form. Once again, this is another form for a linear equation. So writing equations in slope-intercept form. So slope-intercept form is just a review of what we've been doing, right? So if you're taking this out of standard form and putting it into slope-intercept form, you are solving for y. So we had negative 4x plus 5y equals 10. So we're going to add 4x to both sides. So you have your negative 4x plus 4x, right? So we end up having 5y equals 4x plus 10. Then we need to divide by 5 on both sides, and we get y equals 4/5 x plus 10/5, which is 4/5 x plus 2. Right? So this is just a quick little review of what we've been doing. So this is our standard form. This is our slope-intercept form. It has the y-intercept and it has the slope. Okay? Standard form has your x-intercept of negative 5/2 and your y-intercept of 2, right? You just cover up method, divide by 5 on both sides. 10 divided by 5 is 2, so your y-intercept is 2. Your x-intercept is 10 over negative 4, which is negative 5/2. Okay? So that's what's important about standard form is your x and y-intercepts. What's important about slope-intercept form is that it gives you the slope of 4/5 and the y-intercept of 2. Okay? So identify the slope and y-intercept of the line. The equation is in the form of y equals mx plus b. We just talked about that. So the slope of the line is 4/5, rise 4, run 5, and the y-intercept is 2. In the example, which equations form would you use to graph the equation? So you could use either of these to graph the equation, right? Slope-intercept form is pretty nice and convenient, though. So slope-intercept form, the slope and y-intercept are most helpful when graphing a linear equation or a line. The slope and y-intercept are easily determined when the equation is in slope-intercept form. Okay. So rewrite ax plus by equals c, standard form, into slope-intercept form. Explain how you can use this form to identify the slope and the y-intercept of a line when its equation is given in standard form. So if I was going to rewrite this, that's the same thing I just did, except now with variables. So if I'm solving for y, I'm going to have by equals negative ax plus c. I'm going to divide by b everywhere. And I'm left with y equals negative a over b, x plus c over b. Your slope is negative a over b. Your y-intercept is c over b. Okay? Same thing, just with variables, because it makes it look so much more confusing when you use variables versus letters. Makes you guys hyperventilate a little bit, right? Just looks scary. It's not scary, it just looks it. Alright. So write an equation for y minus x, I can't even read. Y minus 4 equals 2/3 times x minus 9 in standard form. So write an equation in standard form. Then use that form to identify the x and y-intercepts. So this right here is called point slope form. So basically it has the point slope form is y minus y1 equals your slope times x minus x1. Okay, so your point is xy and your slope is m. Okay, so basically this point right here is the opposites of these because it's y minus y1. So it's 9, 4, 4 is your point, and your slope is 2/3. So that's what I can take out just from it being in point-slope form. So if I was going to graph this, I could graph this point, and then go up 2 over 3, up 2 over 3, and have my line. Make sense? That's not what they want us to do here because, of course, they want us to, manipulate stuff, just make it look more confusing. All right, so if I was going to turn this into the standard form where I have a number x plus a number y equals just a number, equals your constant, I need to multiply by 3/2 on both sides to get rid of that fraction. Okay. Oh, they're having you multiply each side by 3, not 3/2. Whatever. We can do what they say, I guess, if we must. They want you to multiply by 3. They're going to do it in 2 steps versus 1. So if they multiply by 3, you'd have 3y minus 12 equals 2 times x minus 9. Right? Distribute the 2. So you'd have 3y minus 12 equals 2x minus 18. Add 12 to both sides. You'd have 3y equals 2x minus 6. Divide by 3 on both sides. Or actually, no, sorry, we're going into standard form, not y equals mx plus b. So you're going to subtract 2x on both sides. Negative 2x plus 3y equals negative 6. It's weird going into standard form. You always want to kind of go towards y equals mx plus b, and then you have to retrain your brain. No, I'm not solving for y. Find the x-intercept by substituting 0 for y and solving for x. So if y is 0, then x is going to be, divide by negative 2 on both sides, x is 3. So you're putting in a 0. So you'd have negative 2x equals negative 6. Divide by negative 2 on both sides, and you get x is 3. The x-intercept is 3. For the y-intercept, you plug in a 0 for x. So that, you just cancel that out, divide by 3 on both sides, and you get y equals negative 2. Okay. Find the x-intercept of the line in the example by substituting 0 for y and solving for x in the point-slope form of the equation. Is it easier to find the x-intercept using standard form or point-slope form? Explain. So, subbing is 0 for y. So you'd have 0 minus 4, or negative 4, equals 2/3 times x minus 9. At this point, you're going to have to do a lot more work, right? You're going to have to either FOIL this out, or you're going to multiply by 3/2 or multiply by 3 on both sides. You're going to have quite a bit of work, right? So if I multiplied by 3 on both sides, I would have negative 12 equals 2x minus 18. I'd add 18 to both sides. I'd have 6 equals 2x. I divide by 2 on both sides. X equals 3. So I still get the right answer. It's just more work, right? So the x-intercept is easier to solve for with standard form, right? Standard form is perfect for solving for the x and y-intercepts. Using point-slope form to get your x and y-intercepts is obnoxious. Okay? Explain why you substitute 0 for x in the equation to find the y-intercept. Because the y-intercept is when the line crosses the y-axis, which is at an x value of 0, right? If it's crossing the y-axis, your x value will always be 0 because the y-axis is a vertical line at x equals 0. Choosing an appropriate form of a linear equation. Okay, so determine which form of the linear equation to use to write an equation for the line that passes through these 2 points. Then write the equation of the line. To determine which form to use, identify the given information. 2 points on the line are given, and neither of them is the y-intercept. So write the equation using, so what form do you guys want to use? We can use point slope or slope intercept, and it's really just personal preference. They're saying to use point slope form. Slope intercept form is also fine, right? So either way will work. So the first thing we need to do is find out what is our slope. So y2 minus y1, 6 minus 9 over x2 minus x1, 8 minus negative 4. Bam, bam. 8 plus 4 is 12. 6 minus 9, bam, bam, negative 3. Negative 3 over 12 reduces to negative 1/4. So your slope is negative 1/4. Write the equation in blank form using the point. So we're going to write the equation in, where did I put that? Sorry. What's up? All right, so sorry about that. In point slope form, right, we're going to do point slope form using this point. So this is your x, this is your y. Y minus y1 equals your slope times x minus x1. Okay, we have the point 8, 6. We have a slope of negative 1/4. Could negative 4, 9 have been used to write the equation of the line in part C? Explain. Well, let's plug it in and see if it works, right? So if this works, then yes. Oh, wait, hold on. It does work because right here, it's the other point that they gave you. So you were allowed to use either of the 2 points. So yes, absolutely, because it is a point on the line. Yes, both given points are on the line, so either point can be used to write the equation. Suppose you're given the y-intercept and the slope of a line. Which linear equation form would you use to write the equation of the line? If they're giving you the y-intercept and the slope, you're going to do it in slope-intercept form. Because they gave you the slope and the intercept. The following table provides a summary of the information represented in the examples above. All right, so on the next page, no? Okay, we're going to create it. Let's zoom this out a little bit. All right, so slope-intercept form. That's going to be y equals mx plus b. They give you the m, which is slope. They give you your b, which is your y-intercept. When you're given the slope and the y-intercept, right? Right, we also have point slope. Okay, so point slope is y minus y1 equals slope times x minus x1. This gives you your m, which is your slope. And it gives you x1 comma y1, which is a point on the line. You use this when they give you a point and the slope. And your third form is standard form. That's your number x plus number y equals just a number, equals your constant. A, B, and C are real numbers. A and B are not both 0. So when would you use this? When given a horizontal or vertical line and one point on the line. Alright, so let's go over to our practice page. So if we were going to rewrite y equals negative 3x, 3 halves x plus 6 into standard form, identify the x-intercept of the line. Okay, so if we're going to put this into standard form, right now it is in slope-intercept form. So to put this in standard form, I'm going to multiply by 2 on both sides. So I get 2y equals negative 3x plus 12, right? Multiplying by 2 everywhere. So then I'm going to add 3x to both sides. So I'm going to get 3x plus 2y equals 12, and that is standard form. All right, so what is my x-intercept? My x-intercept is when y is 0. So I divide by 3 on both sides, and I get x equals 4. Rewrite this standard equation into slope-intercept form. So I need it to be y equals mx plus b. So I have 9y equals 7x plus 18, right? I add 7x to both sides. I divide by 9 everywhere. And I'm left with y equals 7/9 x plus 2. So my slope is 7/9, and my y-intercept is 2. So my slope is 7/9. My y-intercept is 2. This one is in point slope form. Identify the y-intercept of the line. So we want to write this into slope-intercept form from point slope form. So right now it has a point of -3, -1, and a slope of 4. All right, so let's distribute this. We have y plus 1 equals 4x plus 12. Subtract 1 from both sides. Y equals 4x plus 11. They want to know, what is the y-intercept? The y-intercept is 11. Your slope is 4. Write the next one in standard form. Identify the x and y-intercepts of the line. So this is in point slope form, and we want it in standard form. So the first thing we're going to do is multiply by 3 on both sides. We have 3y plus 75 equals -5 times x minus 12. 3y plus 75 equals -5x plus 60. And we're writing this in standard form. So we're going to have 5x plus 3y equals -60 minus 75, -15. So that is the standard form. X and y-intercepts. Your x-intercept is when y is 0. Divide by 5 on both sides, we get -3. So your x-intercept, -3. Your y-intercept, divide by 3 on both sides, and you get -5. Are we okay on this? All right, so what about determine which form of a linear equation to use to write an equation for the line with the given characteristics. Then write the equation of the line in that form. So a line that passes through these 2 points. So the first thing I need is my slope. y2 minus y1 over x2 minus x1. Bam, 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 bam. 9 over 12. 9 over 12 reduces to 3 goes in there 3 times, 3 goes in there 4 times, 3/4. So my slope is 3/4. So I'm going to put this into, I'm going to do it into, it doesn't say which form to use, so the easiest form to use would be point slope form, right? Because we have a slope and we have a point. So which point do you guys want to use? Do you want to use the first point or the second point? It's totally your choice. You want to just go with the first point? Y minus y1, y minus -4, or y plus 4 equals slope times x minus -5, or x plus 5. Done. Right? The opposite signs. And your slope. A vertical line through 8, 1. Well, a vertical line is going to be a what? This is y, this is x. Is it going to be an x equals or a y equals for vertical? A vertical line, every single x value is the same or every single y value is the same on a vertical line? Every single x value is the same. So x equals 8. All right. We have a slope, we have a y-intercept. Y equals m x plus b. I'm going to use slope-intercept form because I have everything I need. This one has a point and a slope. Which form do you think I'm going to use? If I'm given a point and a slope, which form should I use? Anybody? A point and a slope. Which form? Point-slope form. Y minus y1 equals slope times x minus -3, x plus 3. I have this point, -3, 6, and a slope of 11/13. You were asked to rewrite -9x plus 4y equals 14 to use the slope of the line. Would you rewrite the equation in slope-intercept form or point-slope form? Explain. Point-slope or slope-intercept? Which one's going to be easier to do? Given standard form, which one's easier to get into? Point-slope or slope-intercept? Isn't it easier to put that into y equals mx plus b? Yeah. So 4y equals 9x plus 14. Divide by 4. Y equals 9/4 x plus 7/2. So it's definitely slope-intercept form. That's going to be easier. Right? Slope-intercept form is way easier to get into. Find the x and y intercepts of the graph. Explain how you can use these intercepts to find the x and y intercepts of any line in standard form. So the x and y intercepts. The x-intercept is when y is 0, so it's going to be c over a. Your y-intercept is when x is 0, so that's going to be c over b. Explain how you can use these intercepts to find the x and y intercepts of any line in standard form. You can use these coefficients always, right? So, I mean, I personally like the cover-up method, but you can always use these just by substituting. So, you can substitute values in c over a to find the x-intercept of any line and c over b to find the y-intercept of any line. All right, so now your homework is going to be page 229 and 230 so that you guys can practice a little bit more on 4.7. We hope you enjoyed the lesson. Like and subscribe, and have a great day.